All right, folks, it's Bass Action, back in action here. In this video, we're going to look at some solutions, some algebraic solutions for our systems of three variables. Before I get into that, though, I want to do a quick review of the vocabulary from the previous video. Example 2, we can see, says that we're going to be solving an inconsistent system. And if it's an inconsistent system, that means, from the previous video, that this should be a no solution. Now, normally you're not going to know what the final answer is supposed to be when you start, but again, we just wanted to review some vocabulary. Example 3 says that our system is going to be consistent and dependent, which means that this should have, when we're done, an infinite number of solutions, meaning there's an infinite number of points that these three planes will have in common. Now, let's get into the actual algebra. We're going to have two strategies for solving these. We're going to use substitution and elimination. Most of the time, we'll be using elimination as our strategy, although on the next page, I will show you an example where substitution is our better choice. What we're going to do in order to do our elimination is we need to choose one of our variables to eliminate. More often than not, it doesn't matter which one you choose, although if you happen to have a situation where maybe the signs are already different and the coefficients are the same, then you might want to focus on that variable. This one doesn't have any particular benefit of one variable over another, so I have already decided that I am going to eliminate x. Okay, I just pre-decided that, no particular reason why. Now, our goal when we eliminate a variable is to get the coefficients to match, but their signs to be opposite. So in order to eliminate an x, what I'm going to do in my first step is I'm going to take equation A and I'm going to multiply it by 2, and I'm going to take equation C and I'm going to multiply it by a -3. When I do that, what I end up with is a 12x plus a 24y minus, didn't mean to write a plus there, minus a 16z, I like to cross my z's so they don't at all look like a 2, equals 48. And then my -3 times equation C is a -12x minus a 24y plus a 21z equals a -78. Now my goal was to eliminate x, but when I add these two equations together, I see the x's drop out and the y's drop out. That leaves me with a z value, 5z equals a -30, or z equals a -6. Now that's unusual for both variables to drop out, and we could take this z value and substitute it back in up above, utilizing our third equation B, and start to solve for the remaining variables, do another system. What I'm going to do instead is I'm going to use my third equation. We always have to use all three equations, and I'm going to just eliminate x again, okay? So I'm going to take 2 times equation B and a -3 times equation A. You're always going to need to use some equation twice, but you have to use all three. That's part of why it's nice to keep track of what you're doing, because then you can clearly see that you've used all three, A, B, and C. Now, when I go ahead and I do that step, 2 times B will give me an 18x plus a 36y minus a 24z equals 60. And then -3 times A is a -18x minus a 36y plus a 24z equals a -72. And when I add those together, I see the x's are gone, the y's are gone, and this time the z's are gone. You might have done this as your very first step, in which case you wouldn't have had to do anything twice, because what I end up with is 0 equals a -12. And since clearly 0 can never equal a -12, my answer is in fact no solution, meaning there are no points in common for all three planes. The next one that we're going to look at is our infinite solution. Again, I just want to emphasize this. You won't normally know what solution you're supposed to have from the beginning. But what I do notice when I first start scanning these three equations, trying to decide what variable to eliminate, what stands out to me through experience, okay, is that these two equations are effectively the same. Equation A, if I divide everything by 2, I end up with 2x minus 3y plus 2z equals 6. And if I take equation B and I divide it by 3, I get 2x minus 3y plus 2z equals 6. So I can see from the very beginning that two of my equations are in fact the same equation. So that's a clue that I'm probably going to end up with this infinite solution, but we're going to go ahead and keep going anyways, because more often than not, you won't see that from the beginning. So what I'm going to do is I'm going to, again, choose to eliminate x. Why am I choosing x? No particular reason. I just chose x to eliminate. So what I'm going to do is I'm going to take a negative 5 times equation A, and I'm going to take 2 times equation C. And when I do that, I get a negative 10x plus a 15y minus a 10z equals a negative 30. And I'm going to have a 10x minus a 16y plus a 20z equals a 40. Remember, if I'm trying to eliminate x, I'm trying to get the coefficients on the x's to be the same but opposite signs. Now, when I add these together, my x's drop out like I wanted. I have a negative y plus a 10z equals a 10. And for right now, I'm going to, I can stop right there. Since I know, though, that this is going to be an infinite solution, so let's say we kept working and all of our variables dropped out and we ended up with an always true statement, similar to what we have right here, but they would be the same. So I would do the same process and everything dropped out, but I had a 0 and a 0, for example. That's another way of seeing the infinite solution. Now, on this problem, since we know it's going to be an infinite solution, I've given an additional instruction from the beginning that we are going to write a final solution in terms of z. When you have these infinite solutions, these consistent and dependent systems, we will write a solution in terms of a particular variable. When we do that, there are choices. You won't normally be told necessarily that it needs to be in terms of z. You would be allowed to choose. I'm just going to tell you in my instruction, I want this to be in terms of z. That means that the equation that I have left here, okay, when I'm at this point right here, when I get to this step, if I want my solution in terms of z, that means that I want to rearrange this so that it becomes a y equals, and I'm going to initially think a couple ways I can do it. I'll say a negative y equals a negative 10z plus 10. That's one option. Then I can go ahead and solve this for y and say 10z minus 10. So now I have a solution in terms of z, meaning I could choose a value for z and get a value for y. That's what we're thinking, is we would substitute in z and we would get our y. This is the part that's usually confusing for students. The next thing that we're going to do is we're going to take that equation for z that we've just, in terms of z, we're going to take this y and we're going to substitute it into one of our other equations. So I'm going to take that equation for y and I'm going to substitute it into my equation c. Okay, so now I'm going to have a 5x minus an 8, and I'm going to substitute in that y. I'm looking from up here, the original equation c, and And I'm going to substitute in this 10z minus 10. And then I'll still have my plus z equals my 20. And now I'm going to solve this so it becomes an x equals something in terms of z. So then I'll have my 5x minus my 80z plus an 80, you gotta be really careful with your signs, plus a 10z equals a 20. Keep going. 5x minus 70z. I'm going to kick that 80 to the other side. Gives me a negative 60. I'm going to go ahead and just continue my algebra. 5x, moving the 70z over, 70z minus 60. So my final answer is x equals 14z minus 12. These equations are what we're going to say in terms of z. So when we write our solution, when you look at these, for example, in the back of the textbook, the way it will be written will look like this. They'll have an x value, they'll say 14z minus 12, comma, the y value will become a 10z minus 10, and then they'll say z. So that's how they'll write their triple. This was the x, this was the y, and everything was in terms of z. Okay, that's usually the hardest part for students. Just remember, if you didn't see in the beginning it would have been an infinite solution, you would have had to go through the algebra to get down to some type of an always true statement before you would know to do this.